Hello everyone. In this video, I am explaining what are partition values and types of partition values. When we want to refer to a part of data, then we use these partition values. These partition values divide the distribution into a certain number of more or less equal parts. To find out these partition values, first we need to arrange the data in ascending or descending order. There are mainly three types of partition values. They are quartiles, deciles, and percentiles. Let us see what are quartiles first. These quartiles divide the whole distribution into four parts. See here, if you have here the given distribution is represented like this, then four parts. This first part is called as Q1, named as Q1, which is lower quartile. This is the middle quartile, second quartile, Q2, and this Q3 is the third quartile. When it divides the whole distribution into four parts, there will be three quartiles. Q1 is first quartile, which is 1 by 4th part of data, which is also called as lower quartile. Means the values below Q1 represents 25% of the data. Q2 is the second quartile, which is equal to half of the data, which is also called as a median. Any values which fall below Q2 represents 50% of the data. Then similarly Q3 is the third quartile, which is also called as upper quartile, which represent 3 by 4th part of data. So values which fall below Q3 represent 75% of the data. So here there will be minimum value and here there will be maximum value, because we are arranging the data in the ascending order or in the descending order. Here I have arranged it in the ascending order. So minimum first, maximum next. So this is the meaning of quartiles. Now deciles means deciles divide the whole distribution into 10 parts. So totally there are 9 deciles which are named as D1, D2, D3, so on up to D9. Similarly, percentiles means they divide the whole distribution into 100 parts. So there are 99 percentiles, P1, P2, P3, so on up to P99. So Q2 is nothing but it divides the whole distribution into two parts and it represents 50% of the data. So here D1 means 10% of the data, 20% of the data, 30% of the data, like that. Therefore, D5 represents 50% of the data, that is same as a Q2. Then P50 represents 50% of the data, which is same as Q2 and D5. So in terms of percentiles means it divides the distribution into 100 equal parts. Therefore, you will have 99 percentiles. And in case of deciles, that divides the whole distribution into 10 parts. Therefore, there will be 9 deciles. Then accordingly we will get the 10%, 20%, 30%, so on. Here we will get 25% of the data is falling below Q1, 50% of the data is falling below Q2, and 75% of the data is falling below Q3. In the case of deciles, from D minimum to D1, D2, like that, D9, then up to maximum here. Then here D5 means below D5 50% of the data falls. These are called as partition values. So if you want to calculate the number of observations which fall below 50% of the given data, then these kind of deciles and percentiles or quartiles will help. Now let us see how to find these quartiles or deciles or percentiles when the data is given. So you know that there are two different types of data. One is ungrouped data and another is grouped data. Under ungrouped data also you have data without frequencies and data with the frequencies. So if you have ungrouped data without frequencies, if you want to find out Q1, then that is first quartile, value corresponding to 1 by 4 into n plus 1th observation. You have to arrange the data in ascending order first. Then you have to calculate n plus 1 by 4. Then you have to find the value corresponding to n plus 1 by 4th observation, that is Q1. So it is easy to remember. Q1 means 1/4 of the distribution. Q2 means half of the distribution. Q3 means 3/4 of the distribution. The same values must be written here. Then n plus 1. Q2 means value corresponding to 1 by 2 into n plus 1th observation. Q3 means value corresponding to 3 by 4 into n plus 1th observation. Now, if you have ungrouped data with frequencies, then in that case, Q1 is value corresponding to 1 by 4 into n plus 1th cumulative frequency. So, in the case of frequencies, capital N means total frequency. Here we use, for a raw data, we use small letter n, that is number of observations. Here we use the total frequency and we have to find out cumulative frequency also. Q1 means value corresponding to 1 by 4 into n plus 1th cumulative frequency. Q2 means value corresponding to 1 by 2 into n plus 1th cumulative frequency. Q3 means value corresponding to 3 by 4th into n plus 1th cumulative frequency. So these things you have to remember. That is for ungrouped data. Now for deciles and percentiles also same thing. Deciles and percentiles. So if you want D1, then it is same as this. For ungrouped data with the frequencies, D1 means here 1 by 10. Instead of 1 by 4 now, you will have 1 by 10 into n plus 1th observation. Similarly, D2 means 2 by 10 into n plus 1th observation. Therefore, in general, Di means I by 10 into n plus 1th observation, because we are dividing into 10 parts. Here we are dividing into 4 parts. So Q2 means here 2 by 4, Q3 means 3 by 4 and so on. Similarly for percentiles, Pi equal to I by 100 into n plus 1th observation. That is for ungrouped data without frequencies. And for ungrouped data with the frequencies, the same thing, but you will have capital letter and I by 100 into n plus 1th observation corresponding to I by 100 into n plus 1th cumulative frequency. Similarly for Di equal to I by 10 into capital N plus 1th cumulative frequency, observation corresponding to this cumulative frequency. Now for grouped data, so if you want to find out ith quartile or ith decile or ith percentile, Qi equal to, this is the formula, L plus In by 4 minus C divided by F into H. Similarly, you have here deciles Di and Pi also. For grouped data means the data will be in terms of class intervals. So L means lower limit of the ith quartile class, H is the width of ith quartile class, F is frequency of ith quartile class, C is cumulative frequency of pre-ith quartile class, capital N means total frequencies. This is these are the descriptions for the terms used in the formula. So Di equal to, similarly you can find out same as this, capital L plus In divided by, you have 10 instead of 4 now, minus C whole divided by F into H. Then for percentiles, Pi equal to L plus In divided by 100 minus C divided by F into H. These are the formulae to find out deciles and percentiles when you have grouped data. So I will explain all this with the examples. See the first question. Find quartiles for this given data. So the first thing you have to do is you have to arrange the data in ascending order. 2, 3, then 6, 8, then 10, 12 and 15. Totally there are 7 observations, n equal to 7. ungrouped data without frequencies. Therefore, I need to find out now Q1, Q2 and Q3. So what is Q1? That is value corresponding to 1 by 4 into n plus 1th observation. So that I have to find out, which is equal to n is 7, 7 plus 1, 8 by 4 means second observation. Which is the second observation? That is 3. Therefore, Q1 equal to 3. Q2 is 1 by 2 into n plus 1th observation. So, which is equal to again 7 plus 1, 8 by 2, which is 4, fourth observation, which is 1, 2, 3, 4, 8. Then Q3 is 3 by 4 into n plus 1th observation. So, which is equal to 7 plus 1, 8. 8 by 4 is 2. 3 2s is 6. Sixth observation in this arranged data. So, which is equal to 12. Therefore, the whole distribution is divided into now 4 equal parts. So, this is your Q1, this is Q2, this is Q3. So, 25% of the data has 2 data values 2, 3. 50% of the data has 4 data values 2, 3, 6, 8. And 75% of the data has 2, 3, 6, 8, 10, 12. These many data values. See, next problem, find the quartiles for this data. So here n is equal to 10. Now it is even. There are 10 data points. So Q1 equal to Q2 equal to Q3 equal to these values we have to find out. It is already in ascending order. So Q1 is 1 by 4 into n plus 1th observation. So you have here, now it is even, so n plus 1 will be odd. Therefore, you won't get the whole number as the value. So it is 11 by 4. 11 by 4 means 2.25th observation. So 2.25 observe, which is that it is in between second and third observation. So in this case, it is how to find the quartile, that is second observation plus this value 0.25 into third observation minus second observation. So what is second observation? 3 plus 0.25 into 3 minus 3. Third observation is 3 minus 3, that is 0. So which is equal to 3. In the case of Q2, in the same way, 1 by 2 into n plus 1th observation. So, which is equal to 10 plus 1, 11 by 2 means 5.5th observation. So, again the same way, that is 5th observation plus 0.5 into 6th observation minus 5th observation. So, what is 5th observation here? 5 plus 0.5 into 6th observation is 6 and 6 minus 5, that gives you 1. So therefore Q2 is 5.5. Now similarly you have to find out Q3, that is 3 by 4 into n plus 1th observation. So here 3 by 4 into 10 plus 1, 11. So 11 by 4, again it is 2.25. 2.25 into 3 is 6.75th observation. So which is equal to 6th observation plus 0.75 into 7th minus 6th observation. 7th minus 6th observation, which is equal to which is 6th observation? 6 plus 0.75 into 7th is 6 minus 6 again, which is 0, that is equal to 6. So this is how we calculate the partition values when number of observations is even. Same method, but only this thing you have to remember. So this data is ungrouped and without frequencies. Earlier number of observations were odd, here number of observations are even. Now see next problem, find quartiles for this data. So here X and F, that is 20, 40, 60, 80 and frequency 7, 5, 4, 3. So this is ungrouped data with the frequencies. Therefore, here I have to find out the total frequency and the cumulative frequency. N equal to 19 and the cumulative frequency CF, which is 7, 7 plus 5, 12, 12 plus 4, 16, 16 plus 3, 19. So now Q1 equal to 1 by 4 into N plus 1th cumulative frequency value. So you have to find out 19 plus 1, 20 by 4, which is nothing but 5. So where comes the cumulative frequency 5? From 0 to 7 cumulative frequency, all data values are equal to 20. So 5 comes within this range, its data value is 20. So Q1 equal to 20. Q2 is 1 by 2 into N plus 1th cumulative frequency value. The value corresponding to cumulative frequency, this. Capital N is 19 plus 1, 20 by 2, 10th cumulative frequency value. So from 8 to 12 means 10 comes within this. So Q2 equal to 40. Then Q3 is 3 by 4 into N plus 1th cumulative frequency value. So which is equal to 3 by 4 into 20, which is 15. So value corresponding to the cumulative frequency 15, that comes within this. So the data value is 60. So hence we got Q1 is 20, Q2 is 40 and Q3 is 60. So very easy because 4 data point values are given here. So I have given an example where you have ungrouped data with the frequencies. Now find Q1 and Q3 for the following data. So here this grouped data with frequencies. So class intervals are given here 0 to 10, 10 to 20, 20 to 30, 30 to 40 and 40 to 50. Here the frequencies 3, 5, 7, 9, 4. Then we want cumulative frequency, that is 3, 5, 3, 8, 7 plus 8, 15, 15 plus 9, 24, 24 plus 4, 28. So total frequency is equal to 28. We have the formula Qi equal to L plus In divided by 4 minus C divided by F into H. We need the quartile class now to get the lower limit of the quartile class. So how to calculate the quartile class? That is first quartile class, then second quartile class and third quartile class we need. First quartile for class is for Q1, second quartile class is for Q2 and the third quartile class is for Q3. So here now to find Q1 we need 1 into N divided by 4, that is 28 by 4, which is 7. So the class corresponding to this cumulative frequency is the first quartile class. So where this 7 cumulative frequency comes up to 3, this is 0 to 10, then up to 8, therefore 7 comes within this. So this is the first quartile class. This is first quartile class. So we got first quartile class now. So Q1 is lower limit of first quartile class 10 plus In by 4, we got this as 7 minus cumulative, C means cumulative frequency of pre-quartile class, pre-first quartile class, that is 3. This is the cumulative frequency of first quartile class. Before that, the cumulative frequency of the class which is occurring previously to this first quartile class, which is 3, divided by frequency of the first quartile class, that is 5 into H means width of the quartile class 10. So simplify all this, you will get 10 plus 4 by 5 into 10, that is 5 ones 5, 2s 4 into 2, that is equal to 18. Therefore first quartile is equal to 18. Similarly, you need the second quartile. For that, you need second quartile class. So 2n by 4 you have to find out. 2 into 28 by 4, which is equal to 40. So this cumulative frequency 14. The class corresponding to the cumulative frequency 14. Up to 15 here means 14 comes within this. Therefore, this is the second quartile class. Second quartile class. What is lower limit of second quartile class? 20 to 30 means 20 plus in by 4, that is 2n by 4, we got it as 14 minus cumulative frequency of the pre-second quartile class, that is before this, which is 8, divided by f is frequency of the quartile class is 7, second quartile class, into width of the quartile class is 10. So let us simplify this. 20 plus 6 by 7 into 10, which is equal to 20 plus 60 by 7, which is approximately 28.57. This is the second quartile median, which is not asked in the question, but I have shown how to find that. Q3 we need. So Q3, in the same way, we need to find out 3n by 4, which is 3 into 28 by 4, which is equal to 21. So cumulative frequency 21. That comes within this. So class corresponding to this cumulative frequency is third quartile class. So lower limit Q3 equal to 30 plus this value 21 minus pre third quartile class cumulative frequency is 15. So divided by frequency of this third quartile class is 9 into width is 10, which is equal to, simplify all this, you will get the value as 36.66. So this is how we calculate the quartiles for grouped data. Now finding deciles and percentiles. So calculate D5 for the following data, and you have to find out P40 also, that is percentile. 40% of the data falls below which value, that we have to find out. This is ungrouped data without frequencies. So first we have to arrange the data in the ascending order. So when we arrange the data in ascending order, we will get 0, 1, 5, 6, 7, 8, 9, 10, 12, 12, 13, 14, 16, then 19 and 19. Totally there are 15 observations. Now I want D5. D5 equal to 5 into n plus 1th divided by 10th observation, the value corresponding to this observation. So 15 plus 1, 16 by 10, 5 into 16 by 10th observation, so which is nothing but here 8th value. So which is the 8th observation, 3, 6, 7, 8, which is 10. So D5 equal to 10. So this is the data point or data value below which or 50% of the data falls. Now similarly you want to find out P40. P40 is 40 into n plus 1 by 100th observation, that we have to find out. So which is equal to 40 into n plus 1 is 16 by 100. 16 by 100. So this cancels, 2 2s are 2 5s. Then you will get it as 6.4th value. Now how to get 6.4th values from this given data, that is 6th observation, 6th value plus 0.4 into 7th value minus 6th value in the observation. So what is 6th value in the observation? This is 8. So 8 plus 0.4 into 7th value is 9. So 9 minus 8 is 1. So which is equal to 8.4. So from this value 8.4 means approximately here in between 8 and 9, 8.4, the 40% of the data falls. You see, if you want to calculate P50, which is 50% of the data, so that is 50 into n plus 1 by 100th observation, which is equal to 16 by 2, which is 8th value. What is the 8th value in the data? That is 10. So which P50 equal to 10, which is same as D5. D5 gives you 50% of the data distribution, and P50 is also the data values which fall below P50 are 50% of the data. So which both are same. Even if you calculate Q2, that also comes out to be 10. See here, find D3 and P80 for the following data. This is ungrouped data with the frequencies. So X, F, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Find cumulative frequency is 2, 7, 17, 31, 47, 67, 80, 89, 96, 96 plus 4, 100. Now here we want to find out D3, which is equal to 3 into n plus 1 by 10th cumulative frequency value. So which is equal to 3 into 10 plus 100 plus 1, which is 101 by 10th cumulative frequency value. So which is equal to, you will get 30.30th cumulative frequency value. So 30.30 cumulative frequency. So 30.3 comes within 31. So this will be somewhere in between here, 30.3 cumulative frequency. When you want the exact value of D3, approximation you can say it as 20, but when you want the exact value of D3 will be somewhere in between 15 and 20. So the method to calculate now is, so which is equal to, now D3 is simple interpolation you have to use. D3 minus 15 divided by then this data value. Its next data value is 20. 20 minus 15, which is equal to, same way here, 30.3 minus 17, this cumulative frequency value here, this value minus 17, then 31 minus 17 divided by 31 minus 17. You have to simplify this expression. So that gives you D3 equal to 15 plus 5 into 13.3 divided by 40, which is equal to 19.75. Now similarly, if you want to find out P80, the same method, P80 equal to 80 into n plus 1 by 100th cumulative frequency value. That is equal to 80.8 cumulative frequency value, where 80.8 cumulative frequency comes. So 80.8 means that comes here between 80 to 89, 80.8, and here comes P80. Use that simple interpolation now. So on an approximation, P80 can be concluded as 35. Now we want the exact value of P80, then it is calculated like this: P80 minus 35 divided by 40 minus 35, which is next value minus this value. Then similarly 80.8 minus 80 divided by 89 minus 80. So on simplification you will get value of P80 as 35.44. From this data value, from this value, 80% of the data falls below this value. Now see the last problem. Find D4 and P10 for the following data. This is grouped data. So class interval 0 to 10, 10 to 20, 20 to 30, 30 to 40 and 40 to 50. Then frequencies 3, 5, 7, 9, 4. Then you have to find out cumulative frequency 3, 3 plus 5, 8, 8 plus 7, 15, 15 plus 9, 24, 24 plus 4, 28. So capital N equal to 28. Now I need D4, therefore formula is 4 plus IN by 10 minus C divided by F into H. So D4 equal to, first we need fourth decile class. So that is 4 into 28 divided by 10, which which is equal to 28 into 2 by 5, that gives you 11.2 cumulative frequency. The value corresponding to the cumulative frequency 11.2, that comes within 8 to 15, that is here. So this is your fourth decile class. This is your decile class. So what is lower limit of this decile class? 20 plus this value is 11.2 minus cumulative frequency just before this decile class, that is 8, divided by frequency of the decile class 7 into width of the decile class 10. Let us simplify all this. You will get D4 equal to 24.57. So this is the below this value 40% of the data false. Then similarly we need to find out P10. So which is equal to L plus 10n by 100 minus C divided by F into H. We need 10th percentile class. So 10 into 28 by 100, which gives you 2.8. So the cumulative value corresponding to the cumulative frequency 2.8, that comes within this. Okay, within this. Therefore, this is the percentile class. So what is the lower limit of percentile class? 0 plus this value is 2.8 minus cumulative frequency just before the percentile class. This itself is the first percentile class. This itself is the percentile class. Just before this, there is no cumulative frequency, which is taken as 0 divided by frequency of the percentile class 3 into height of the, in the sense width of the class interval, that is 10. So you will get 2.8 by 3. The value is 9.33. That is from 0 to 10. So from this value, below this value, 10%. 10% of the data means very less. 10% of the data false. So I have given examples for all different kinds of data with the frequencies, without frequencies, as well as grouped data. I hope you understood how to find deciles, percentiles and quartiles. Thank you for watching.